I had two commenters asking me if I could talk about two problems in graph theory, and I will try to do them tomorrow. I've just been kind of busy today, but I thought that this would be a better base point anyway to just talk about this single problem, and it's called the Seven Bridges of Konigsberg problem, and this is really where graph theory began. So, in order to explain the problem, I guess you need to take a step back into the 1700s. So there was this problem in the city of Konigsberg, which is where the problem gets its name from, and people were asking, well, we have seven bridges, there's this piece of land here, and this one, and in the south, and in the east. Can I, on a given afternoon, do a walk around the city, traversing each bridge only once? And people thought about this, and eventually Euler solved it. Or Euler's the one credited with solving it. Like, I don't know, I'm not too familiar about the history of the problem, but he chose a more analytical approach rather than just brute forcing the problem, because you don't really learn anything by brute forcing it. So what he did was, he asked himself, does it really matter how big this island is in the middle? Does it really matter how big any of the pieces of land are? And any reasonable person would say no, so there's not really any reason why we shouldn't be able to just shrink all of the land in this down to a single point, which is what we do. So these things, if we'll actually draw, we're going to call vertices, or singular is vertex, and well, we have these bridges as well. Does it really matter how wide they are? We're going to assume that you've been on like some sort of Weight Watchers diet and you dropped a couple of the dimensions. And it really doesn't matter how thick these things are as well. So we're just going to draw these guys as lines. And if I sketch these guys in, you end up with a graph that looks kind of like this. So the key observation is that if you're on a walk, you're going to come into a point from another point. So let's say I go here, and then when I'm at this point, I'm going to leave. So, for any given point, you're going to come in once, and then you're going to leave once. So we have this thing called the degree, which is basically the number of edges that come away from or into a point. The number of edges connected to a point is probably a better way of putting it. It should be an even number because you're coming into and you're leaving it. And there are only two exceptions to this rule. So that is, if you start at a point, you're only going to leave it once. And if you finish at a point, you're only going to enter that point once. So what we can say is that if there is a traversable path, most of your points or vertices are going to be even, and you can only allow yourself two exceptions or up to two exceptions. So if we look at our problem here, we see that we've got one connection here, 2, 3, so this has a degree of 3. 1, 2, 3, 4, 5 here. This guy, again, has a degree of 3, and so does this guy. So this is actually an impossible graph to traverse, and just as a quick pointer, we say that a graph is Eulerian if it does have this traversable property, so you can make your way all around the city, so to speak. And yeah, that's the seven bridges problem. So it wasn't possible. I'm pretty sure after World War II there was like 2 of the bridges in this city that got taken out, and it became a, I think it was like this one and this one, and then it did become a traversable path. I'm not really sure. Maybe someone can let me know in the comments, but yeah. That's the seven bridges problem. Thanks for watching. If you have any questions, please leave them on the Reddit. Thank you.